What's up, guys? This is Waleed, and today's problem is the floating cylinders. So let's just get things clear up. I'm not going to use any of the numbers in here. We're just going to use two numbers because most of the stuff is going to cancel. But let's just be clear on a couple things, the variables. So P, W, that's mean the density of the water. Okay, density of the water. PC is going to be density of the cylinder. And then what else do I need to make sure? And then you just figure out L1 and L2. But I just need to make sure these are clear. Okay, density. So we have two cylinders, and we need to find the ratio of H2 divided by H1. We need the ratio of, so it's this guy, those two. Okay, so the force, the buoyant force minus the weight of the cylinder is going to equal to ma in the y direction. That's just Newton's law. Okay. The buoyant force is acting up. The weight of the cylinder is acting down. Okay. So summation of them is ma. Okay. But since this guy is going to 0 because the two cylinders are not in motion, okay, static, so we can say that may equal to 0. So that means that the buoyant force is going to equal to the weight of the cylinder. Okay. So what is a buoyant force? Buoyant force is just the weight of the displaced fluid. Okay. So what's the weight of the displaced fluid? It's just what is inside of here. Okay. What's inside of this cylinder right here. Okay. So that means the buoyant force, let's put it, let's just take it on the side over here. So that means the buoyant force is going to be equal to the density of the water multiplied times the area times the height. Okay, the volume of this part from here to here. Okay, does that make sense? Because the weight of the water is only in this area, the displaced water. So times the pi r1 squared, and then times the height. And the height in this case is L1 minus H1. So L1 minus H1. Okay? Kind of make sense? Alright, cool. Let me clear this guy out. And let's do it again. So now, what's the weight of the cylinder? Let me put this in here. Weight of the cylinder is going to be equal to the density of the cylinder times the volume of the cylinder. So the volume of the cylinder is going to be same thing, pi r1 squared, but the height of the cylinder is the whole height. So this is L1. Does that make sense? Alright, so now let's put these two guys equal to each other. So we get P, density of the water, pi r1 squared, L1 minus H1. It's going to be equal to density of cylinder, pi r1 squared, L1. Okay, so we can cancel out those guys, and then I'll take we need to solve for H1 for the for this height in here. So let's take the density of the water to the other side. So that will give us PC L1 divided by PW. Okay, and then this is equal to L1 minus H1. So solving for H, that will give us that L1 minus PCL1 divided by PW. Okay. So that give us that, I mean, we can take the L1 out. So H1, let me put this guy, H1 is going to be equal to L1, 1 minus PC divided by PW. All right, so these numbers are kind of nice. So in the first question, they asked us for H2 divided by H1. All right, so H2 will be the same. Okay, so H2 will be L2 1 minus PC divided by PW. Okay, so now let's find the ratio of H1 divided by H2. So L1, 1 minus the density of the water, the density of the cylinder. Let me clean this guy. PC, PW divided by L2 minus PC and then PW. So those guys can cancel out. So what we get is H2 divided by H1 is equal to, oh, this is H1, this is H1. So L2 divided by L1. Okay, so on the back of the question, my L2 was 10, and then my L1 was 20. So 10 divided by 20 equal to 1 over 2, which is 0.5. Cool. All right, guys, if you have any question, let me know. Hope this clears it up. Bye. Take care.